Okay, today we're going to learn how to factor by using the ACB method. Some other people might call this the AC method. Maybe, I don't know, I guess in check. But we go with the ACB. You'll see kind of why in a second. Remember, we've already learned factoring using the greatest common factor, factor by grouping. So if you're struggling with those, go to some earlier videos because both of those are in here. Okay, so factoring using the ACB method, usually we want to have a trinomial when we do this. Polynomial, 3 terms. Sometimes we'll have some cases of binomial too, but most of the time we have trinomials. And we're going to follow these 5 steps. So take a second and write down in your notes these 5 steps so you can follow along as we're working on a problem. Okay? The first problem we're going to have, it's going to say factor. So factor. So facta. We have 3x squared minus 13x minus 10. Okay, so first step we want to find a, b, and c. A, b, and c come from a general form of ax squared plus bx plus c. So notice that they're all kind of, even though we don't have an equal sign here, but they're all on the same side, okay? So if you do have an equation, you have some on one side, some on the other, bring them all to the same side. The a term is always with x squared, b is always with x, and c is the one without a variable on it, the constant. Okay? So in this case, step 1, a is going to equal 3, b is going to equal negative 13, and c will equal negative 10. Okay? Don't forget the negative signs, okay? Okay, great. So step 2, multiply a and c. Okay, 3 times negative 10 is negative 30. Not bad. 40% of the way done. Bam. Step 3. Now we want to find 2 numbers that multiply to negative 30 and add together to give you negative 13. So multiply to negative 30 and, that's the key word, they have to do both, add to negative 13. Well, the best way to kind of do this, don't worry about the negative sign too much. Once you find the numbers that do that, then you worry about the signs. Just think of factors of 30. Well, we know 30 could be divided by 2. 2 times 15, okay, that gives us negative 13. So we can try that out. So say we have 2 and 15. Okay. And then we got to think, is there any way I could rearrange these to get negative 13? While keeping that they multiply to negative 30. Well, negative 15, and how I knew these were it, negative 15 minus 2 gives me 13. So negative 15 plus a positive 2 gives me negative 13. That's good. Negative 2 plus a positive 15 gives me a positive 13. That's not a negative. So this guy is the one that needs to be negative. So this is our golden combination. Now some of you might be saying, what about 10 and 3? Those multiply to 30 and add to negative and add to 13. You're right, but let's look at them. 10 and 3. Okay, in order to multiply to negative 30, one of them has to be negative, not both. Or else, they'll be a positive. So if you put the negative with 10, now when you add these together, that's going to give you a negative 7. You put it with negative 3, add them together, a positive 7. But if you put them with both, yeah, they add together to negative 13, but negative 10 times negative 3 is a positive 30. So it violates that. And remember, the numbers have to do both of these. Multiply to one of them, to negative 30, and add to negative 13. So that's why those two don't work. These satisfy both of them. So you just got to be careful there. Sometimes you're going to get a situation like this where they both work, but you got to use the logic a little bit to make sure it satisfies both. Okay, step 4, now we can rewrite this. So here's the key to all of this. We know that we have a negative 13x. Okay? And this has 3 terms here, so we can't factor by grouping because we need 4. But we feel comfortable with factoring by grouping. So what we're going to do is take this trinomial and break it off into 4 terms so we can factor by grouping. And I know that negative 13 equals 2 plus a negative 15. So keeping this idea, I'm going to come down here, negative 13x is going to equal 2x minus 15x. So take a second and let that absorb in your head. Negative 13x equals 2x minus 15x. So now I'm going to take this and substitute that in for 13x. Okay, let me draw the arrow. Maybe a little bit more towards. Just so it doesn't get in the way. So now what I'm going to have is 3x squared. Keep that guy the same. And I'm going to now break apart this negative 13x to be 2x plus 2x minus 15x. So I didn't break any equality. Negative 13x is the same thing as 2x minus 15x. And then this guy will stay the same. So the powerful key here is I just went from having 3 terms to 4 terms. And now I can do factor by grouping. Okay, so factor by grouping. Hopefully, again, if you have trouble with this, go watch previous videos. Greatest common factor between these two is an x. You're left with 3x plus 2. Okay. Greatest common factor between these, well, there's no x here, so it's not an x. 15 and 10 both have 5 in it. But since the first term's negative, we need to factor out a negative 5. So minus 5. And then we're left with 3x plus 2. And then with grouping, now we have these 2 terms. We see they share a 3x plus 2 in common, so I'll factor that out. Okay? And after you factor that out, what we're left with is x minus 5. And here you go. You just factored it using the ACB method. Okay? So take a second to kind of look, make sure you understand each step. Okay, pause the video if you have to. And the key thing to realize here, again, we went from 3 terms to 4 terms. Okay, now I'm going to put up an example for you to try on your own. So pause the video after you see the example up here. Try it, then play the video, and see where you might have gone wrong. Okay, so let's say we have 6x squared plus 8x minus 14. So factor that using this ACB method, and then we'll talk. Welcome back. Now there are a few ways you could actually have solved this guy. We could use the ACB method, okay? But before you do any factoring, the first thing you always want to do is see if there's a greatest common factor. It just makes your life a lot easier, okay? And with this guy here, we see that each of them share a 2 in common. So I'm going to factor out a 2. And remember, when you're factoring, you're pretty much dividing. So I'm left with 3x squared plus 4x minus 7. Now what I'm going to do is I'm going to apply the ACB method on this guy right here. And then we'll worry about the 2 later. So again, write down your A, B, and C. Remember looking at this guy. So A is 3, B is 4, C is negative 7. That's step 1. Step 2, multiply A and C. So 3 times negative 7 equals negative 21. And then step 3, you got to find 2 terms of negative 21. And we'll do it like last time. So find 2 numbers that multiply to negative 21 and add to 4. Well, we got 21. You think of the numbers that could go into 21. 21 and 1, but they don't add together to give you 4. 21 can't be divided by 2. Oh, 3. 21 is 3 times 7. And then if I think to myself, 7 minus 3 is 4. Oh, okay. Let's see if these work. Okay, so I need it to be a negative 21, so I know one of these have to be negative. But when I add them together, it has to be a positive 4. Well, if 7 were negative, adding them together would give me a negative 4. So that means that 3 has to be negative. So negative 3 times 7 is a negative 21. And then negative 3 plus 7 is a positive 4. Bang! That's that magic set of numbers you found. So now I'll rewrite this. And remember, 2 is just hanging out up front. So 3x squared. And instead of 4x, I'm now going to break it apart to minus 3x plus 7x. And this guy right here equaled 4x. Minus 7. Now you can do factor by grouping. So we're going to keep the 2 way out here. Okay, greatest common factor between these two is a 3x. And we're left with x minus 3x divided by 3x is just 1. Greatest common factor between these two is a 7. It's not a negative 7 because this guy was positive. And then we're left with x minus 7 divided by 7 is 1. Factor again. They both have an x minus 1 in common. So 2 is just chilling. Take out an x minus 1. And then we're left with 3x plus 7. And here you go. Completely factored. And if you were to go backwards and try to get up to this, when you go to distribute the 2, you only pick 1 to distribute it into. Okay? It's multiplication, the order doesn't matter, but you're not going to distribute it in here and then distribute it in there. If you were adding those two terms, maybe. The final thing to keep in mind about factoring. Realize we have 3 terms up here that depend on addition and subtraction. But in our factored form here, all these depend on multiplication. That's the key point. So you go from an expression that depends on addition and subtraction to one that depends on multiplication. So keep that in the back of your mind as we work in this chapter. Okay? Hope that helped.